For the function g, whose graph is given, determine whether each of the following integrals is positive, negative, or zero. Explain your reasoning. So we're looking at a graph given here, and we can see the different interval areas as we look across the graph. When we were talking about graphs before, remember we said that if we had the derivative, if it was above the graph, then it meant the derivative was positive. If it was below the graph, it meant the derivative was negative. Remember that? Well, here we're talking about the same kind of idea, but this time, instead of looking at the derivative, we're looking at an integral. But when we look at an integral, if the area is above the x-axis, then the integral is positive. If the area is below the x-axis, then the integral is negative. So let's look at the first one here. We have the integral from 0 to 4, and we're looking at this region. So 0 to 4 is from here to here. So this right here is red, the integral from 0 to 4 of g of t. So I'll read it again. The integral from 0 to 4 of g of t. That means that you start at 0 and you go to 4. So we're looking at this area all right in here. So that area is all above the x-axis. So that area is going to be positive. Let's look at the next one. For the next one, we're looking at the integral from 6 to 8. So that means we're starting at 6 and we're going to 8. The integral from 6 to 8. And we're looking at being bound by our curve and the x-axis. So that would be this area right here. And that area is all below the x-axis. So this is all negative. So this integral here would be negative. Let's look at the next one. We're looking at the integral from 4 to 10. So for this one, here's 10 right here. For this one, we're looking at this piece and this piece. So all this under here and all this up here. This one's a little bit hard to tell because there's some positive and some negative. It looks to me like this green part at the bottom is bigger than this green part at the top. So I think that there is more negative. So I'm going to say it's negative. And my reasoning is this piece looks bigger. So there's more in the negative region. Let's look at the next one. The integral from 0 to 8. So it's all of this and all of this. So this is the same kind of idea again, where you have some positive and some negative. But the positive piece looks much larger to me. So I'm going to say this one is positive because we're looking at more above the x-axis than below the x-axis. Let's look at the next one. Each of the regions A, B, and C are enclosed by the graph of f and the x-axis has an area of 3. Find the value of each of the following definite integrals. A definite integral means that it has the ends. An indefinite integral, it would just look like this, the integral of f of x. And it wouldn't have our end values here and here. A definite integral has our ending values, so you know where you're starting and where you're ending. So between -4, which is right here, and 0, which is right here. Now it says that each of the regions has an area of 3. So I'm going to say this one's -3 because it's below the x-axis. I'll say this one is 3 because it's above the x-axis. And then for the last part, I'll say C is -3 again because it is below the x-axis. So now I'm looking at from 0 to -4. So this piece right here. Starting at -4, working our way to 0. Integral from -4 to 0. So it looks like the -3 and the +3 are going to cancel each other out. And it looks like we're going to have an integral value of 0. So let's look at the next one. We have the integral from -4, which is right here, to 2. So now I'm looking at this whole thing. Well, this was -3, this was 3, this was -3. So that means that we need all of them. We need -3 plus 3 plus -3. And that looks like it's going to give me a value of -3. So the integral from -4 to 2. So all the way across is going to be -3. Let's look at the last one. The graph of f is shown. Evaluate each integral by interpreting it in terms of areas. Okay, we can do this. We just need to figure out the area of each different piece. So for our first integral, we have from 0 to 2. Here's 0, here's 2. So we're looking at this area right here, this little trapezoid. So if we want to figure out the area, we can just count up the squares. It looks to me, if we cut it right here, like we have a triangle and we have a rectangle. So I'll say the area is the area of the rectangle, which has a base of 2 and a height of 1, plus the area of the triangle, which is 1/2 a base of 2 and a height of 2. See right here, 1, 2, and a height 1, 2. So that looks like we're going to get 2 plus 2 times 2 is 4, half of 4 is 2, so 2 plus 2. So it looks like we have an area of 4. And if we were to count it through, look, 1, 2, 3, and then this one and this one come together to make 4. So we were able to figure out our area. Now, sometimes it's hard to see, like those last two came together as halves. We could see it. Sometimes they're not a half though, and it's a little bit harder. So it's a little bit easier, in my opinion, to look for the shapes and then use the shapes to help us find the area. Let's try the next one, part B. We have the integral from 0, so right here, to 5, right here. So that means we need the area under this whole piece. So let's see here. How can we break this apart? You can break it however you want, whatever makes sense to you. I think I'm going to break it right here because I already know that this piece is 4. And then if I do that, I can break it into a rectangle and a triangle. So I already have my 4 because that's what I figured out in part A. If I didn't figure out part A already, I could have split it and had the base and the height for the triangle and the rectangle as well. And then right here, I have 1 times 3. So that's going to give me an area of 3. And then I have a little triangle right here. So that'll be a half the base, which is 1, 2, times the height, which is 1, 2, 3. So 2 times 3 is 6. Half of 6 is 3. So it looks like this time I get 4 plus 3 plus 3, so 10. So we have to split our figure to figure out what we're looking at in order to find the area. Let's try the next one. The integral from 5, so right here, to 7. So we're looking at the area under our curve. So all of this, the integral from 5 to 7. Well, that looks like a triangle. So our area will be a half the base, which in this case is the top, but that's okay, 2, times the height, 1, 2, 3. So it looks like half of 6, so 3, but the whole thing is below the axis, so -3. Let's try one more. So we have the integral from 0 to 9. All right, so this whole thing, the integral from 0 to 9. Well, let's see if we can figure this out. We already found from 0 to 5 right here, and that was 10. So we already got this whole piece taken care of. And when we're looking at these integrals, we can add up the areas and that'll work. We got this whole piece taken care of right here. We just figured that out, and that was our -3. So that was from 5 to 7. So this was -3. So it looks like the only piece we have yet to figure out is this last piece right here. So let's see, what can we do to make some areas there? I think I'm going to split it right here and make a square and a triangle. So I have the area is 10 minus our 3, and then this whole piece is below the axis as well, so it's going to be minus. And let's see if I can figure it out. So it looks like my square is 4, and then here I have a triangle, so 1/2. The base is 2, and the height is 1. 2 times 1 is 2, half of 2 is 1, 4 plus 1 is 5. So 10 minus 3, and this whole piece becomes -5. So it looks like for my area, I get 2.